Go to the next speaker, is May Nagappa. And May is professor assistant professor at the Rochester Institute of Technology, and he is doing research in mining software repository and analyzing big data. And his talk is going to be about software engineering for mobile apps.
Okay. Thank you, Max, for the introduction. I'm May Nagappan from RIT, and this is work that I've done with a lot of people, but this particular paper I worked with Imad Shihab from Bukhara, who could not be here for personal reasons. But today I'll be talking about some future trends in software engineering research for mobile applications. I'll start with a little bit about me, because I'm here and I won't talk much about Imad. I'll give some background information on what I mean by mobile applications and what information is there. I'll then try to show how mobile applications and software that we've looked at before are actually apples and oranges, and that they are different and there are new challenges to be looked at. And then I'll look at some current trends and some future opportunities as well. So just a little bit about me, and for the most part of the talk, I'm not going to talk about some of my research, but also about the entire team of people from around the world who are working on this. So some of the papers that I've kind of worked on in mobile applications are here, but you can find more of that in the paper as well. But all of this was possible because I was able to work with these researchers and I was able to pick their brains, but also these students who I could work with. Right? If not for them, none of this would have been possible. So a shout out to them and thank you so much for all the help. And I have to say, when it comes to mobile apps research, we've come a long way as a community, as a software engineering community. So this was actually a review in one of the first papers that we submitted, is how is your hypothesis on mobile applications different from stationary applications? And I was like, what is stationary applications? The app is not mobile, it's on a mobile device, right? So from there, last year we actually had a Shonen meeting with 30 researchers from around the world just talking about mobile app store analytics, right? Just about what information that we can gain from mobile applications. But what are these mobile applications? And just to give you some background on these, this is kind of the ecosystem that they are in, and the different stakeholders that are there in the ecosystem. There are developers who may build these apps, but they include advertisements or analytics in part of their applications that are provided by other developers. Then they release it in something called an app store, and I will kind of briefly touch upon this a little bit later on why this is important. Right? This app store, for the most part, is provided by platforms like the Android platform or the iOS platform, but there are also a lot of third-party stores. If you look at Chinese markets, a lot of apps are sold to third-party markets which are not part of the platform. These are then installed on devices, very different devices, which again are manufactured by a completely different set of people and used by end users from around the world with different backgrounds. There are almost 600 million mobile app users in India. Farmers now who don't have an education are using mobile applications, so you can't assume a lot of things in mobile applications that you did with other software, that they will have a certain background or not. So we need to really help people, rocket scientists to farmers. So with all of these stakeholders, I think mobile applications are actually very different from the other applications that we've studied before. And I think there are three big differences between them. Right? The first difference, I think, is at the code level. We found out that mobile applications actually are much smaller than the typical applications that we study. So the two spikes there we see are Eclipse and Apache. right? If you have read any paper from software engineering paper from 5-10 years before, you'll see that Eclipse is almost a case study system in any empirical study, right? But Eclipse is used by software developers, built by software developers. But mobile applications sometimes are very small. Actually, there's one mobile app in there called Frozen Bubble. And the app is, and I kid you not, you open the app, it shows you bubbles on the screen, you touch the bubble, and the bubble pops. That's all the app does. And it has more than 10 million downloads. There has not been a commit to that app since 2009. Talk about aging and evolution, right? There's nothing that has changed, and the developer still makes money out of that app. So what are these, when the app is so different, there are completely different challenges now when it comes to mind, right? The second difference is monetization, right? A lot of apps are now monetized through the free or freemium model. Free, monetized through advertisements, or freemium, where they are monetized through in-app purchases. And in the past, software was typically sold as, shrink wrap, where you actually buy it, or sell it through support services, or through subscriptions. But now, with the change in the model, there are different challenges that come about. Because when you put in an advertisement in a mobile app screen, which is only about 4 inches big or 5 inches big, you have to worry about how much real estate can I use for the advertisement before the end user feels angry and not use the application. They're not going to use the application because of my monetization model and not because of the application itself. So that brings some new challenges. And we actually are noticing that in the mobile world, the use of advertisements, the revenue through advertisements, and the revenue through in-app purchases are going up, and the revenue through paid applications are actually going down, right? And finally, this is the biggest difference that I think between mobile applications and the other applications is that it is distributed through centralized app stores. These app stores are a democratic platform. Adobe, which is a multi-billion-dollar company, can sell Photoshop on the same platform that this one developer is selling his frozen bubble through, right? So now everybody has an equal platform to compete against. They have the same tools that are there in these platforms. You have the same amount of space for showing images, same amount of space for descriptions. You have a democratized platform for releasing your applications. But beyond that, now you have a central place for these applications. So what happens is they're able to push updates as quickly as they want. They don't need an entire cloud infrastructure in the background to push updates to their end users. They just need to push it to the store, and the store will automatically push it to all the users. So they can make updates every day. And that is something that we are noticing is most applications have about a 2-week release cycle. 2 to 4 weeks they are making updates. There are applications that get updated every day, though the everyday reasons are much different from the 3-week, 4-week reasons, right? Sometimes it's only like a typo fix that's done in a daily update. The other big advantage of these centralized app stores is more than just changing how software is developed, they also now provide a lot of data, not just to the users and developers, but to us researchers as well. We know what is being built. We know what people think about it. This was not available before, right? In the past, you had bug reporting software. There is no way a user is going to go into Bugzilla or Jira and report a bug for a mobile application. Right? By giving these simple tools to give feedback, now users know what features to build, what bugs to fix, what problems that are there. And of course, finally, there's a lot of money involved as well. So it's worth billions of dollars, and a billion people are now using it, so the impact that you can have is a lot. So as one of the members of this research community working with mobile applications, we need you. We need you. There's a lot more interesting problems, so we need you to spend time in solving some of these problems. And what these problems are is what I'll kind of talk about next in this talk. So some framework is needed to discuss the current trends and some future challenges. And what I used was the typical development lifecycle. I have, from requirements through maintenance and monetization. And I'll kind of talk a little bit about the current trends in these areas and what some future challenges for each of these areas are. When it comes to requirements, it's been made a lot easier through these user reviews. So you can mine these user reviews, and you can get what features users want, what kind of problems users have, and so this has become a much more easier platform to do. Although there are some big challenges in it, and as Gabriele said right before, this is unstructured data, and you can see here, it just says, like usual, app does not work, crashes after sign-in. Or even worse, is good for nothing, worst app ever made. Right? So obviously, NLP techniques or any automated technique is only as good as the data. You cannot actually mine anything from good for nothing app, worst app ever made, except that the app is bad. I mean, you cannot improve the app in any way from that data. Right? So how do you remove the noise from this? But use something just as small. The review above is just a sentence as well. How do you use that to kind of build the next set of requirements? Right? So I think a big area in mining reviews is to build better techniques that use smaller set of reviews, right? And reviews that are not very long, and frankly, reviews with a lot of spelling mistakes. And I'm not even going into the other problem which someone else pointed out in the morning about languages. We're only looking at English languages so far. There's, again, people from around the world using these apps in other languages, and they're leaving reviews in those languages. How do you mine that information? Right? If we are using only NLP techniques in English, then you're building these next set of requirements and features only for English-speaking users, which is a much smaller market than the other language users. So how are you going to solve that problem? I think that's a very interesting challenge that is still yet to be solved. The next thing that I want to talk about is energy use in mobile applications. Right? Energy is a limited resource in mobile devices, and the cost of energy in mobile devices is not as much as the inconvenience that is there in these energy issues. But I won't go into much detail because Abram Hibble is going to talk about a lot of this in his talk. If you want a brief version, you can read the 2 paragraphs in my paper. If you want the full scale, read Abram's paper. Right? The next thing that a lot of people have focused on is on security. And in security, a lot of work has been done on malware detection. There's a tool called FlowDried and a few other tools that have come out in the last year or so where they've really upped the ante in trying to find these malware applications. But the future in this is, I think that there's a few interesting problems to be solved. One is reducing false positives in these analyses. Right? It's a very big problem when you kind of recommend something as a malware especially, and it's not. Imagine your app goes through and finds out that the Trump application is a malware and you say that it is. You're going to see that Trump is going to probably sue you for classifying his app as malware. So you don't want that. Right? So you have to be careful about these false positives. And from talking to some of the people who are doing this malware detection research, a big issue is the lack of ground truth malware data. Right? Some of these malware data applications that they have are still years old, and nobody is creating malware of that type anymore. So a big challenge for them is to get a lot of good data. So how are you going to generate, detect, and share this malware data? In terms of development, we found that functionally equivalent apps, right? So apps like WordPress, Google Authenticator, and the Facebook or not the app, but the Facebook SDK that is used in apps, but for the BlackBerry platform and for the Android platform, are actually very different. So depending on the platform, the size of the libraries change, and the dependencies also change a lot. So there's a lot of interesting challenge when it comes to developing for cross-platform applications. So these are some of the frameworks that you can use to build these cross-platform apps. But the problems that they bring about are, what is the time to develop an application using these frameworks? Does one framework help you build the app quicker than the other? But the trade-off being performance and security, right? For example, Adobe Air has a lot of security issues. So if you're building an app through Adobe Air, you could be building a very insecure app. Right? So how are you, as a developer, making choices to build apps that are cross-platform? Are you going to build it natively? Are you going to use a framework to build it? So there are a lot of challenges yet left to be solved in this area as well. The next area is testing. And a lot of work has been done on automated GUI testing. There's a tool called Dino Drive from Georgia Tech, Evo Drive from UC Irvine. I think it's called Monkey Lab from William and Mary. And Google has one called Monkey Runner as well. And all of these are trying to exercise the app in various ways and try to exploit all possible paths through the GUI. And an issue that they're currently facing is coverage. Right? If there is a sign-in page in the middle, what happens? An app is not able to automatically, the testing tool is not automatically able to sign in. So how do you interrupt it with a human input? Right? And the other challenge is with respect to platforms, again, and devices. So this is actually a real picture from a mobile app company where they have all of these devices set up and they're trying to test on all of these devices. There's actually several companies now that let you rent devices on the cloud so that you can test on multiple platforms and multiple devices. We've done some initial work on this, but there still is a lot of open problems in testing for different devices and different platforms at the same time. When it comes to maintenance, we've looked at maintenance of advertising libraries. There are more than 50 advertising libraries, right? And these libraries change quickly. And I remember Thomas was kind of saying that, you know, there's a company that went under. A lot of these companies go under. Right? And we found that apps are still using libraries from companies that have gone under. So they're using dead code. They're calling ad companies for advertisements. The company doesn't exist. So they don't get advertisements. They don't get money. Right? So how are you going to solve this problem for the mobile app developers? We also have a lot of work that's been done on Android API calls and the quality of these API calls. Is there a relationship between ratings and the amount of churn that happens in the Android APIs? And what kind of maintenance effort is there in maintaining these APIs? But with these maintenance of ad libraries, I think a new challenge in maintenance is that there's now a lot of data that is being coming in from runtime information. So a lot of apps use these analytics libraries that provide a lot of runtime information. As researchers, we still don't have access to it, but I think that there is a lot of potential here, right? We know when users are using these apps. We know at what point they're quitting these apps. We know where the apps are crashing. We know how long they're using these apps. With all of this information, I think we can definitely improve the operations of these apps. How can we use the knowledge that we gained from mining network logs to provide operations information? To how can we mine these usage logs of mobile applications to provide information to developers on how these apps are being used? A big challenge that is there in the maintenance data is that in mobile app stores, you do not have historical information. You have only the latest version of the app. You have reviews from maybe 6 months before or a year before. They do not provide you with all the historical information. You don't know what the ratings of the app was a year before. So one way how we solve it is we're mining this information on a daily basis. Right? We're going and collecting information from Google Play Store or the App Store on a daily basis. So we have to maintain this historical information if we want to study evolution. We want to study how software has been, these mobile apps have been maintained in the past. And finally, when it comes to monetization, there's two ways: A, the consumer pays or the advertiser pays. If we found that advertisements can be very expensive, they can consume more energy, they can consume more network, they can consume more performance. And so there's an interesting challenge of how do you provide the information to developers on a cost-benefit analysis? At what point will these applications become too bad to use that the user will not use them because of the advertisements? And to kind of conclude, I'll say that app stores have changed the way in which we distribute apps. And there are several other app stores to mine. I even consider GitHub to be kind of an app store because it provides a platform, an equal platform for everybody to contribute, and everybody can consume from the same. And with the Internet of Things, I think it's just going to change with a lot more app stores, a lot more apps. So I think there's a lot of potential for new researchers to come in and start working on this. Thank you. Question?
You mentioned in the speech that mining of user reviews for mobile applications may be useful for developers. Do you think that it is a reliable source of information, considering the fact that many of such reviews are written by software developers themselves, and after that the reviews are going good by the so-called snowball effect? And the most known example is a fake antivirus application for Android when it has about 4.7 out of 5 rating, and it did just nothing.
Yeah. So
okay, thank you.
It is definitely a big problem. So a big challenge in this data is noise. How do you remove noisy reviews? They're not obviously good reviews, right? In the sense that given by the same developer. One thing is we don't usually look at the 5-star reviews because there's not much useful information in a 5-star review. If you look at 1- and 2-star reviews, they contain more useful information on what needs to be fixed or what needs to be added. So, and we assume that the developer is not going to give themselves a 1- or 2-star review. Also, even in apps, about 90% of the store in my experience so far are not applications that really, they're probably tutorial apps and things like that. I would say about 100,000 of the million apps that are there, 100,000 in the million apps that are there in the App Store are actually apps, and the rest are all like tutorial apps and things like that. Other question?
Okay, my question is more about circle of life. Okay, so well, I don't want to start all the way from the age of the Earth, which is only about 2,000 years old. But so when we started out, there used to be thick clients, right? Then came the web platform, right? People did that, and then mobile devices came, right? And then people again started building individual apps. Now it's the world of web apps, right? So what's next? Are we kind of spinning our wheels, or are we kind of making progress?
So I think there's going to be more, in my opinion, I think there's going to become more specialized apps, right? Apps that are going to do one thing and one thing only. With, I think the Internet of Things, there's going to be now apps for the refrigerator. One app is going to be apps that are going to detect what is there in the refrigerator, and another app is going to be an app that's going to determine how nutritional the things are there in the refrigerator. And another app is going to probably determine if everything in the refrigerator is good or bad, or when is it going bad. So I think there's going to be very specific apps that are going to be built for very specific purposes. But then that's just my opinion. I don't know. I think in 10 years' time we're going to be there. But from a perspective of why we should study this now that we haven't done this before is applications like the Unix utilities or things were there 30 years before, and apps are pretty much similar to them doing something small. But we did not study such utilities before, like widgets from for Windows 95 or something. We did not study them before because data on them was not available. I think now with mobile applications, data is available, and so it's easier for us to study.
So is the data actually available? Because you were saying the app stores are democratic platforms, but on the other hand, whereas with open source systems we can access any repository we want, everything, it seems it's a bit of a closed world now.
In some ways it is closed, it's not easy to mine, let me put it that way, right? You need to have a crawler that goes to the store every day, you need to make sure that the crawler is not missing any particular day's worth of data. So it is difficult to get the data. But when it comes to source code, yes, we definitely do not have the entire development history. But if we mine every app binary, surprisingly, most binaries are not obfuscated. We can reverse engineer a lot of these binaries to get the source code. We were able to study library evolution in apps over the last 4 or 5 years. Right? So it is possible to study the evolution of code from reverse engineering these apps. A small percentage is what was obfuscated.
Thanks, great talk. What kind of information do you envision for us researchers to extract from platforms such as Steam? Because the dynamics are very different
Yes.
from an app store or from Play Store.
Yeah. Each store is going to have different kinds of information, right? Like in Steam, you will have, I think even the reviews are going to be very different because gamers might have different expectations, right? So definitely I think that nothing's going to translate from one store to another. Maybe the techniques can, right? But I think the data is going to be different. What you can get from the data is very different. I think it's going to be more obfuscated applications in Steam. You may not be able to reverse engineer them as much. But yes, so there are going to be much different data sources. But I think the techniques can share. We can share it.
But do you envision what kind of software engineering specific information we can extract from that? Haven't you thought about it yet?
So no. So Steam is something that I think is going to be in the future. I haven't looked at it yet.
It's the present.
Well, it is the present, but I'm saying as researchers, we haven't looked into any Steam data yet. I haven't seen a single paper using Steam data yet, right? And I'm sure that the first time it's written, there's going to be complaints that this is not software engineering. And in 3 years, there's going to be an entire session on Steam. Right? So, yeah.
Thank you.
Hello, May. Thank you very much for your presentation. I think that maybe in the future it's going to be more complicated to collect information from the APKs because by default now, if you use Android Studio to build your Android application, by default they propose to obfuscate your application. So maybe in the future, all the applications are going to be obfuscated and it's going to be more complicated to decompile these applications.
It definitely might be. It definitely might be. But I think, if there are enough people doing it, there might be tools to again break into it. Right? There's a big enough market to exploit these applications that tools are going to be built for that as well. And we don't even have to worry as researchers to build it. People who want to make money will build it. Right? So
Hi, thank you for presentation. I have a question. Are you able to retrieve information related to usage metrics for the mobile applications in general, in terms of the frequency, for example, of usage by users? Because I read an article recently that large number of mobile applications are not used after 2 or 3 weeks after downloading. So can that be used, if that's retrievable, can that be used for usage patterns development and so on? Thank you.
So usage patterns are, you can get that data, but as a researcher, it's very difficult to get that data. There's a lot of companies, there's one called Criticism, there's one called App Annie. There are these companies that actually collect this usage information for the developers. So if you as a student or as a professor or a researcher who wants to get into mining user data, then I think the best way forward is to partner with some of these companies and work with them. Outside of that scope, it's very difficult to get usage data. There has been in the past one example from Berkeley where they were able to provide performance recommendations to users. So the real challenge for you is what are you going to provide for the users if they are willing to share the data with you. So if there's a good enough reason, they might use your libraries to give that information away, but that's a challenge. Otherwise, working with these companies might be the best way to get that data.
Thanks a lot.